So this is Miss Plant's video where I'm going to try and explain momentum to you in 5 minutes. Momentum is a higher tier only topic. This is for AQA Combined Science and Physics GCSE. Combined Science will stop at some point, but Physics GCSE has to do the whole lot. So momentum is a vector and it is a property of moving objects. Momentum can be defined as the mass times the velocity of an object. Momentum is given the symbol P and the units are kilogram meters per second. Occasionally you see them quoted as Newton seconds, so just be aware of that. Mass, symbol M, kilograms, velocity, symbol V, meters per second. The units for momentum is a question that's often asked, and if you just remember that momentum is mass times velocity, then to get the units of momentum you just squish the units of mass and velocity together. Kilograms, meters per second, kilogram meters per second. Momentum at Combined Science is not that extensive. You need to know about the law of conservation of momentum, which means that in a closed system momentum is conserved, or more simply, the momentum before a collision is the momentum after a collision. So if we had a situation like this where we have two cars that are going to crash into each other, we can calculate the momentum of this car. It's the mass times velocity, 2,000 times 2, so the momentum of this car is 4,000 kilograms meters per second. The momentum of this car, it's slightly lighter, but it's traveling faster, so it's 1,000 kilograms times minus 4 meters per second, because velocity is a vector, so if it's going in the opposite direction it needs to be a negative, so the momentum of this car is minus 4,000 kilograms meters per second, as in the momentum of these cars, total momentum is 0. So after the collision, the momentum will also be 0, meaning these cars could smash into each other and come to a perfect stop because they have equal and opposite momentum. Momentum before is 0, the momentum after, you can fully expect it to be 0. At Combined Science, that's all you're required to understand. At Physics GCSE, you have to put some actual calculations in. Combined Science, they just might ask you, why does this move backwards, blah, blah, blah. You need to say conservation of momentum, momentum before equals momentum after. They might also ask you to do some calculations. So stop, and if you're doing Combined Science, if you're doing Physics, carry on. Now, for physics, you might have to actually do some calculations related to this momentum, which can be quite tricky. So if we've got, this is an example here of something that's not necessarily going to be 0. So 3 kilograms, 10 meters per second. So the momentum here is 30 kilogram meters per second. 2 kilograms minus 10, the momentum is minus 20 kilogram meters per second. If I add these two numbers together, I get 10. 30 plus minus 20 is 10. So the momentum before is 10 kilogram meters per second. You notice these have dots on them. This is sticky. The idea is these things are going to stick together and we're going to work out what speed they're going to move off with when they've stuck together. So we know that after the momentum is 10 kilogram meters per second because of the conservation of momentum. So long as there are no external forces acting, that's fine. So the mass after is going to be 5 because they've joined together. The momentum after is 10, so we can just use momentum is mass times velocity. So 10 is 5 times velocity, so dividing both sides by 5, 10 divided by 5 is velocity, so 2. So this is going to move this direction with the speed of 2 meters per second after the collision. Might give you other things like that. They are quite tricky. Calculate the momentum before, the momentum after is the same, and then try and find your missing value after that. For physics, the other thing you need to know about is an idea of change in momentum. So in physics, delta, this little triangle thing, represents change. So to write change in momentum, I just write delta P, or the triangle P. And the change in momentum is going to be the mass of an object times its change in velocity, because we assume it's a fixed mass. So the velocity is what changes as things speed up or slow down, so we can measure the change in momentum. Now, there are two equations here. Force is mass times acceleration, and acceleration is v minus u over t. That's final velocity minus initial velocity divided by time. These two equations can combine together. So first of all, I'm going to rewrite v minus u over t as change in velocity divided by change in time. And then because acceleration is change in velocity minus divided by change in time, I'm going to sub it into this equation. So force is mass times change in velocity divided by change in time. And this means that force is equal to the rate of change in momentum. Now, in collisions or accidents, the idea is that we want to decrease the force. The force is what hurts you, what breaks your bones, what knocks you out. So you want to decrease the force. So if force is mass times change in velocity divided by change in time, we need to reduce the denominator or increase the reduce the numerator or increase the denominator. Now, reducing the numerator is all very well, but if you're falling out of plane, you can't change your mass, you can't change your change in velocity. We can increase the time taken for the fall, though. So, and time taken for the impact, sorry. The idea we do that is with things like airbags, helmets, crash mats, seat belts, soft playground surfaces and stuff like that. All of these increase the time taken for you falling. So it's not a smack, it's a slow fall. You get cushioned a bit. They increase the change in time, which reduces the force, which therefore prevents injury.